All right, so yesterday we learned how to solve equations, right? And we learned replacement sets and solution sets, two equations, substituting things in for the variables. Okay, we looked at that yesterday. Today we're going to look at representing relations and interpreting graphs of relations, okay? Talking about functions, graphing ordered pairs, stuff like that. So coordinate system, coordinate plane, that's the big, I have one up there, graph looking. X and Y axis, which one's the X axis? Let's talk about that. X goes this way. X goes this way, that's the first one you do. Y goes this way, okay? X goes this way, Y goes this way. X, Y. Okay, you graph the X first, and then you graph the Y. Okay, origin, where's the origin at on a graph?
The middle.
In the middle, yep, where they intersect. That right there is our origin. Ordered pair, what's an example of ordered pair? Someone give it to me. 2, 2. Okay, written as 2, 2. And if I graph that, I graph the X first, go over 2, and then we go up 2 on the Y. Okay, I'll go over that a little more. Okay. Domain. Do we know much with domain and range? Domain goes with the X's. Range goes with the Y's. Domain, X's, range, Y's. Domain is what? X's, range is what? Y's. Good. So it says express the relation, and then it gives you all these ordered pairs. They want us to write it as a table. So pause. Table looks like this every single time. Okay, you're going to write X, and then you're going to write Y. Now we're going to take each ordered pair, and we're going to put them in the right spot. Okay, so the first ordered pair, what's the X? 4. What's the Y? 3. Next ordered pair, what's the X? -2. -1. Next one? 2, -4. Next one? 0, -4. Okay, so all you're doing there is putting them in a table. Understanding what's the X and what's the Y. Okay, could I put -2 with 3? No, why? Because they're not an ordered pair, okay? You got to have them right across from each other, just like this table does. And look at a little graph in here, okay? Just to practice it, I'm going to draw like 5 tick marks on each side. Let's go over graphing. You guys graph a lot in 8th grade? Yeah. Okay, so this should be a little bit of a review. So looking at 4, 3, what do we do first? Yep, always start at the origin, and then we go 4 right because it's positive and it's on the x-axis. So we go 1, 2, 3, 4. Now we have 3, and we need to, it's a y, so it's up and down, and it's positive, so we need to go up. 1, 2, 3. Okay, I know it's a little rough, but everyone understand how to graph that point? Okay. -2, 1. So I start at the origin, -2, x. To the left, 1, 2, -1. Down, because it's y, yep. Start at the origin again, we have +2 on the x-axis. Right 2, then we have -4 on the y-axis. Down 4. Okay, my last one, I'm at 0. Some people get confused with this one. What do I do if our x is 0? Just stay there, right? Okay, now we move over, -4. Go down 4. Okay, in our table here, okay, they took all those that express as a table. Our table's here. Now it wants us to graph it, so I'm going to go back. Check it here. That's what ours looked like in a nutshell. Okay. Any questions with the graph part? No, we're okay? And then a graph here. Okay, moving on. Now we're getting to domain and range. Okay, so all it did was it took our x values and they put them in this circle over here. Does everyone see that? Yeah. They just took those x values that we had, put them in the domain circle. Okay, same thing with the y's. They just put them in a circle on this side. Okay, what do those arrows mean? What do those arrows in the middle indicate?
With the pairs.
The ordered pair. Yep. So 4 we said went with it. Sorry, 4 went with 3. So we're here. Okay, that's all that's doing. Okay. 2 went with -1, and then these share. Does it matter that 0 and 2 share the same y value? Doesn't matter.
No.
They can do that, right? Okay. In a little bit later of a lesson, we'll talk about different x values and y values that don't work as functions. Okay. But everyone understands the mapping part with domain and range? Yeah? Okay. Mapping here. So mapping, we want that domain. So on this one, don't pay attention to the answer. We're going to draw our little picture, okay, with the domain and range to get practice. So let's start with the domain. Draw yourself a little circle, and then put domain at the top. Then draw yourself a little circle over here, put range. And if you need to remind yourself, remember, domain is x's, range is y's. So put those over there to remind you. So let's start with the first ordered pair, 4, 3. What's my x value? 4. What's my y value? 3. And then just connect them right away. 4 and 3 go together. Okay, next one, -2, -1. What's my x value? -2. What's my y? -1. So we connect them. 2, -4. What's my x? 2. What's my y? Good. And then everyone agree that my x is 0 and my y is -4. Didn't I have to write -4 again on the range? No, is that what you're going to say?
Yeah.
Yep, I don't need to write it again. Okay, because why? It's already there, so I can just connect it that way. Okay? Yeah, Blakeland.
We have to write the numbers like 1 through 10. It doesn't matter.
4.
Any of them?
No. Nope. And then they wrote them as sets. Okay, like that. Any questions so far? Here. Okay. On this one, I know you already have the answer, but let's check it. Okay, let's just start with A. 3, -2. Did they plot that right on the graph or on the table? They plotted that right. Okay. 4, 6. Did they put that right? 5, 2. -1, 3. That one's good. I read the question wrong. It says express the relation as a mapping. What's a mapping? What kind of graph? Remember about range? So we need to decide between one of these two. Okay. So 3, -2. I'm looking at this one. Did they plot that right? 4, 6. 5, 2. -1, 3. Good. So we know that this one is correct. Okay. Why is this one down here wrong? Because they're flipped around, right? They put the range as the x's and they put the domain as the y's. Big no-no. Don't do that, okay? Plot, okay? On this one, it wants us to determine the domain and range of the relation, okay? Domain is what values? X values, ranges, y's, okay? I know it gives you the answer, but let's go through it, okay? Domain, someone raise your hand, tell me what the domain is. Julio. The x's, what are our x's?
3, 4, 5, 1.
Good. Someone raise your hand, tell me what the range is. Zoe.
Y's, -2, 6, 2, and 3.
Good. Domain, x's, range, y's. Nice job. Might help if I put record. Okay, so independent variable. What's an independent variable? What does independent mean? You can be on your own, it changes on its own. What's dependent mean?
It depends on the independent variable.
Depends on somebody else, okay? So let's see what our independent and dependent variable is. So in warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and dependent variables. Which is the independent variable? I know it tells us. Why is temperature the independent variable?
Because you can check
it's on its own, right? Temperature just changes independently on its own. What is our dependent variable?
Electricity.
Why is that the dependent variable?
Because it changes with the climate.
Does. Good. Okay. This one, it says the number of calories you burn increases as the number of minutes that you walk increases. What is our independent variable? So, what are our two variables in this case?
Walking and calories?
Okay, number of calories you burn and the number of minutes.
Yeah.
So, calories and minutes, okay? So, what is the independent variable? I heard it. The time. Time independent. Like, can I handle that clock right now?
Yeah.
Like, could I say it's 10 o'clock right now? No. Okay, I can't change time. Okay, but I can change the number of calories burned by that time. Okay, so number of calories is our dependent variable. Time is our independent variable. Okay, so look for those two variables and think out what makes the most sense for you. This one, in a particular club, as membership dues increase, the number of new members. So what are our two variables?
The membership dues and then members.
Good. What is our independent variable?
Membership dues.
Because it's changing how many people come in the class.
Good. What's our dependent variable?
Number of members.
Good. Another one, the area of a square increases as the length of a side increases. What are our two variables? The area and the length. Okay, what is our independent variable? So let's read it. The area of a square increases as the length of a side increases. As the whatever. Okay, so our independent variable is that length. Area increases as the length. Area would be, in this case, the dependent variable. Okay, so read it carefully. If you need to read it out loud, that'll help. Okay, we're going to work on this tomorrow, actually. So the graph represents the temperature in Miss Ling's classroom on a winter school day. Describe what is happening. What is happening over time as temperature increases or decreases, or as time increases?
It kind of goes
Temperature.
down, up, down, up, down, up.
Yep.
And goes down.
So it starts down. What is it happening in between here? What's going on right here?
It's increasing.
It is increasing, and then what's happening in those little zigzags?
It goes down, up, down, up, down, up.
Decreasing and increasing all at the same time, and then at the end it's decreasing. Good. So what's happening with this graph over time as she's swimming laps? What do these indicate?
Increases, then decreases, then increases again.
Increases and decreases. What happens when she's at 0?
It's at the bottom.
It's at the bottom. Does that mean she's stopped, or is she at a constant speed?
At a constant speed.
At a constant speed. Good. Any questions before I hand out your worksheet?
No.
No.